Speed and velocity is our topic for today. You're going to need your blue Forces in Motion book, and you should be looking at section 1.2. Measuring motion. First, let's review. When you describe location, you need to know the distance and the direction from the reference point. For example, if you were describing the location of your home and you're telling someone how to get to your home, you might use a reference point like a church or City Hall in order to tell them you're going 2 miles east of City Hall. So you give them the distance and the direction from that reference point. The international unit for measuring distance is the meter. Now let's look at speed. Position can change at different rates. Speed is a measure of how fast something moves. To measure speed, you must know distance and time. More speed means you are going more distance. Less speed means you are going less distance in the same amount of time. Take a look at these two animations. Which one has more speed, and how do you know? Well, apparently the clown on his tricycle has more speed, which is easy to tell when you look at it, but if you think about the distance and the time, the kid on the bike goes the same amount of distance, but it takes him more time. Calculating speed. The formula for calculating speed is S equals D divided by T. This stands for distance traveled divided by the time it took. The units for speed, they depend. It depends on what's being measured. Sometimes a unit for speed is not appropriate for one object while it is appropriate for another object, but it will always be a distance unit divided by a time unit. Remember when we're talking about units and you see this fraction bar, you say the word per, so it would be distance per time. Here's some examples. Cars in the United States are measured in miles per hour. Notice, in the US, instead of using the fraction bar, we have a P for per. Everywhere else, using the metric system, you'd see the fraction bar. An appropriate speed for a jet would be kilometers per hour. A snail, however, an appropriate speed would be centimeters per second, because a snail is not going to go a kilometer even in 1 hour. And when we measure the speed of falling objects, we measure them in meters per second. Now it's your turn. On your one of your assignment questions asks you to give your own example of an object and its speed. Try to make sure that the speed is an appropriate speed for that particular object. No, you cannot use any of the ones that I've already given you. Calculating speed. Remembering that speed equals distance divided by time. If I run 80 meters, which is my distance, in 40 seconds, which is my time, then I have a speed of, 80 meters divided by 40 seconds gives you 2 meters per second. How about this one? If I walk 1 meter in 1 second, then I have a speed of, 1 meter divided by 1 second gives you 1 meter per second. And finally, if I swim 50 meters in 25 seconds, what is my speed? 50 meters divided by 25 seconds is 2 meters per second. Later on, we'll learn specifically how to calculate these in a step-by-step kind of fashion. And then from that point on, once we learn the guess method, from that point on, you'll be required to use that anytime we do any sort of math in this assignment or in this course. Now let's talk about average speed. Speed is not usually constant. If you walk from one place to another, or run from one place to another, or drive from one place to another, You don't generally have the exact same speed the whole time, unless you're driving and your parents are using cruise control. For example, cars stop and go regularly. That means their speed is changing. Runners tend to go slower uphill than downhill. Their speed is changing. So the average speed looks at the total distance the object traveled divided by the total time it took, which kind of averages out all those slower and faster points. Take a look here at this picture. This shows a police officer using a radar gun to catch someone's speed. Would that be measuring the average speed, or would it be measuring something called instantaneous speed? Police officer is measuring instantaneous speed. He's getting the speed of the object at one moment in time. However, if you think about someone running a race, they might start off slower and sprint at the finish, or they might start off really fast and then get tired and slow down. So if you think of someone running a race, then you are looking at the average speed. Now let's look at how to graph speed. To graph speed, you use a graph called a distance-time graph. Notice that the distance is on the y-axis and time is on the x-axis. For this graph, the distance is being measured in kilometers and the time is being measured in hours. This is the graph of a plane flight from Phoenix to Denver. So in this case, we can assume that the graph starts at 0. After 1 hour, the plane has gone 200 kilometers. After 4 hours, the plane has gone 800 kilometers. And after 7 hours, the plane has gone 1,400 kilometers. You can use this graph to figure out its speed. And since the graph is a straight line, we can assume that the speed of the plane was constant the entire time. So we said, over the course of this trip, the distance was 1,400 kilometers and the time was 7 hours. So we know speed equals distance divided by time. So we can take 1,200 kilometers divided by 6 hours, and we get the speed of that flight was 200 kilometers per hour. Take a look at your question number 9. Below is a distance-time graph of my position during a race. What was my average speed for the entire race? Notice my speed was not constant throughout that race. It looks like I started off slowly, and then I had some issue here, and then I got a little faster, and at the end I sprinted to the end. So if we're looking for average speed, thankfully we don't have to calculate the speed at each interval. We can calculate the total distance divided by the total time, also known as the rise over run. So distance at the end of my race was 12 kilometers, divided by the 6 hours it took me to run it. I'm not very fast, apparently. 12 kilometers divided by 6 hours is 2 kilometers per hour. On your assignment, take a look at question number 10. Below is a distance-time graph for 3 runners. Who is the fastest? Notice that Bob is the red line, Jane is the black line, and Leroy is the blue line. If you said that Leroy is the fastest, you're correct. Now, using both the distance and the time, calculate Leroy's speed. Remember, you are calculating distance divided by time. And notice here, I know the graph on the time is kind of difficult to tell. He completed the race in 3 hours. Answer that question on your assignment. Then look at question 11. What does the slope of a distance versus time graph show you about the motion of an object? It tells you the speed. The slope is simply the hill, the upward motion of the line on a graph. For questions 12 through 14, look at the zebra on page 21 in your textbook. You should see a graph that looks similar to this, although it's marked out in different colors to kind of make it easier to read. what I want you to determine is what's the difference between a slope of a line that looks like this versus the slope of a line that looks like this, or the slope of a line that looks like this. If we were calculating the actual speed of each slope, we could use that same rise over run method. 1 kilometer divided by 1 hour. In this spot, notice that the distance stays 0. It stays at 3 kilometers for the entire time, divided by 1 hour. Or, at this slope, the rise is 2 kilometers. It goes from 4 to 6, so that's a rise of 2 kilometers, divided by the time of 1 hour. So in this part of the line, just like the zebra in your book, the runner is moving. It's moving, but slowly. In this section of the line, where the line is flat, something has happened. The zebra has stopped. Maybe he got bored and decided to eat some grass, or maybe, who knows. But the runner or the zebra has stopped. In this section of the line, the zebra must have seen a lion because it started sprinting. So the steeper the slope, the faster the object is going. If the line is flat, that means the object has stopped. Now let's talk about velocity. Velocity and speed are related. Velocity is the speed and direction of an object. For example, an airplane moving north at 500 miles per hour is the velocity. You have the speed, but you also have the direction it's going. Or a missile moving toward you at 200 meters per second. That shows you the velocity because it gives you the direction of toward you. So what information do you need to determine the velocity of an object? You need the speed and the direction. Let's compare velocity and speed with a Venn diagram. These are the final 2 questions on your assignment. How are velocity and speed the same? If you said that they both require the distance and the time, then you are correct. In order to figure out both velocity and speed, you need to know the distance the object goes and the time it took to get there. However, they are different because speed does not require a specific direction, whereas velocity does. That means velocity is a vector. Any type of measurement that requires a direction with it is called a vector, and there are multiple types of vectors in the physics world. Alright, that's all I have for you for speed and velocity. If you have any questions, please send me a message.